Now, this is the topology that I'm going to use to explain MPLS, the basic MPLS. With the notepad, what I'm going to do is I'll be assigning the IP address on the interfaces along with a link state routing protocol. It is recommended to use a link state routing protocol when you are using MPLS. Now, when I enable MPLS after this link state routing protocol, MPLS will pick the loopback interface address as the router ID, same like OSPF. And this loopback interface address will become the MPLS ID. So the loopback interface address should be unique as usual. Even in OSPF, it should be unique on every router. If not, there will be conflicts in learning and forming adjacency. In MPLS also, the adjacency will come only if each router has got their own unique router ID or MPLS ID. Also, you should understand this MPLS is not a routing protocol. So the router ID of the neighbor needs to be reachable. I repeat, in MPLS, when router 4 will go to router 3 and say, I am 44444. Router 3 will check the routing table. Do I know 44444? Only yes, I know where is 44444. Router 3 can accept router 4 as a neighbor. Whereas in OSPF, that's not the case. In OSPF, the neighbor's router ID doesn't need to be reached. There's no need for root to reach the neighbor's router ID. Whereas in MPLS, the router ID of the neighbor should be reachable. Only then the neighbor can become my neighbor. Adjacent router can become my neighbor. If I don't know where the neighbor is, then I can't form neighbor. So MPLS also forms neighbor like OSPF. MPLS also uses loopback interface address as the router ID like OSPF. But the difference is this is not a routing protocol, so the router ID should be a reachable address to form neighbor. In another word, I'm trying to say that you must run OSPF on loopback interface also. If you fail to advertise the loopback interface address, then the neighbor will not be knowing about your loopback. And the neighbor cannot form adjacency. So, advertising the loopback interface address is must in OSPF. But if you're planning to use the physical interface as the router ID in MPLS, then it is not needed to advertise loopback interface address. Dynamically, loopback interface addresses are picked up as the router ID. Okay. Now, we are going to use a notepad to configure IP address, OSPF, and MPLS. Also, the MPLS label range can be defined optionally. Every router is going to generate label for every single route in the routing table. Who gives route? OSPF and other routing protocols. For all those routes in the routing table, for each route there will be a label dynamically assigned. If you don't mention the range of label, then it is going to be any label between 16 to 65535. Up to 15 label is reserved. It won't give label 14, 13, 15. From 16 onwards, it will start using any label up to 65535. Labels are available. But if you wish to provide a range and tell router 1, you should use only label from 100 to 199. Router 2, you should use only label between 200 to 299. You can do that, but that is optional. If two routers pick the same label for the network, it is okay. Two routers can have same label, nothing wrong. There's nothing wrong. It won't conflict. Two routers can have same label for same network. That is why assigning range of label is an optional one. But I would like to show you that optional one so that you will know which label is coming from which router. I'm going to give label 400 to 499 to router 4. First the notepad. And the IP address now. You cannot enable MPLS on loopback interface. You know why? Because it's not a physical interface to advertise label. It is not a physical interface to advertise label. So you cannot say this command MPLS IP. This is the command to enable MPLS on the interface. You cannot say that. If you say, it will show some message saying this is not allowed in loopback interface. You can try it later when you do that. And MPLS, this is enough. This command is enough to run MPLS on a router. But I told you, optionally, we will also add range of labels. For that, you need to go to global mode. Come out from the interface and say MPLS label range. I think LDP label range. Let me go to the command prompt and check the command. MPLS label range, correct only. And this is router 1, so I'm going to give 100 to 199. I'm telling don't use any other label other than these range. All right. Now you can verify the MPLS, show MPLS interface. You can see MPLS is running on this interface. And when you enable MPLS, LDP is a part of MPLS, label distribution protocol, which is responsible for generating labels and distributing them, advertising them. And for all IP network, this LDP is working and it is operational. Show MPLS LDP neighbor. You won't find any neighbor because router 2 is not configured. Show MPLS forwarding table. This is going to show you the labels that are allocated. Understand, we don't have any routes now. So no routes, no label. Let's go finish router 2. Now on F0100, this is the address. Another interface, F01 23 2. The range I want to give is 200 to 299. This is not a mandatory configuration. The range command is not mandatory. See, I am not enabling MPLS on loopback interface. I am also not enabling OSPF. I am doing this with intention. Why? I told you if the loopbacks are not learned, MPLS cannot form neighbor. So even after pasting this, MPLS neighbor should not come. Only OSPF neighbor will come, but MPLS neighbor will not come. You see, OSPF neighbor with 111 has come, but can you ping 111? You cannot ping because you have not advertised this network on R1. So R2 don't know to ping this neighbor, don't know the route to ping this neighbor. It is just using the ID to identify OSPF neighbor, but the neighbor is not reached through this address. If the neighbor address is not reachable, MPLS cannot form neighbor. You see, when the MPLS packet, hello packets go in between these two routers, you will see them advertising using the loopback interface. You will see MPLS using the loopback interface to communicate. But when the loopback interface is unknown, the location of whereabout of loopback interface is unknown, it won't form neighbor. You see, I'm taking the LDP packet, which is using 224.0.0.2 multicast address. If you go inside, you see they use this router ID. This is coming from router 1 saying I'm 1111, but router 2 says I don't know 2222. Sorry, I don't know 11111. So router 2 says I don't know 11111. I don't know who you are talking to me. So they don't form neighbor. The command to check the neighborship is show MPLS LDP neighbor. There's no neighbor. But LDP, hello packets are going, you can see that. Yeah, every 5 seconds the hello packet is going. Is it 5 seconds? See the difference between this and this. This is 66 seconds, and the next hello is 70th second. 5 seconds, every 5 seconds. The LDP hellos are going. All right, and we don't have neighbor. The only reason is I did not put the loopback interface under OSPF process. Right. Likewise, when I go to router 1, now you will see the form neighbor. You will see LDP neighbor coming up. See, there's a connection between your IGP protocol. So when you troubleshoot, don't think only the problem is with MPLS configuration. Sometimes you don't have route for MPLS to form neighbors. So you need to also troubleshoot your routing protocol now. Now let's check the neighbor command. Show MPLS LDP neighbor. You can see router 1 and router 2 has used that loopback interface in order to negotiate, in order to know each other to form neighbor. Now if you go to router 1, you can see some labels for some network. At least for one network 2.2.2.2, there will be a label, local label. Show MPLS forwarding table. You see for 2.2.2.2, it has assigned a local label of 101. Because I was telling you should use from 100 to 199. If you go to router 2, you will see show MPLS forwarding table. You can see this guy is using only label 200. As I said, you should use from 200 to 299. Now on router 3, oh no, I'm actually changing here. It should be 34. Between 3 and 4, I would like to have only 34. I don't want 24. Again, if you don't give this, see what happens. It will take label range between 16 to 65,535. Let's see. Copy. Okay. Right. You're right. You're right. Okay. Let us paste this. on router 3, as soon as I paste this, first the OSPF will come and then the MPLS neighbor will come. First OSPF should come, it has come, and then MPLS should come. It has also come. Now let us check. Show MPLS interface. You can see two physical interfaces running MPLS. Never try on loopback, it won't accept. And show MPLS forwarding table. You can see it started using label from 16 onwards locally. I want to set the range. MPLS label range. You are 3, router 3, so 300 to 399. Now this will not label range change because 3 label is old dynamic range to go out of range. Okay. So if you want to use these labels, then you have to do this. Clear or say no MPLS IP. Stop the MPLS. Set the new range and then put MPLS. Okay. Now go and verify if you should see labels starting from 300. You see? Earlier it was 16, 17, 18. Now it's 300, 301, 302. Going to router 4's configuration. All right. Router 4. First the OSPF, then the MPLS. Okay, OSPF is done. And here comes MPLS. Did I set range? I think I did not set range. EL. Because already it has started using the label range between 16, between 16 to 65 by 35. I have to clear. Set the range and put the MPLS back. Okay, now the last router. Find out 5 and F00 F00 is 45.5. Range is 500. Done. Now, first OSPF, then MPLS. Okay, now I would like to trace throughout and show you that the labels are going to be used for packet forwarding. Trace route 1.1.1.1 is the source. You can see the labels. See, router 5 is going to router 4. So it puts a label 400 given by router 4 and sending to 4. 300 is given by router 3. 200 is given by router 2. And then at last it is sending without any label to router 1. It will not put any label to the final router to avoid two lookups, MPLS lookup and route lookup. More about this I'll discuss with you tomorrow. We call this as PHP, penultimate hop hopping. We'll do that in detail later. So you can see here labels involved. No MPLS, then you will not see any labels. You don't see these things in first place if you don't have MPLS. When you trace it out from here, when here you can see labels involved. This is the label of router 2 to identify 555. This is the label of router 3 to identify 555. This is the label of router 4 to identify 555. If you want to see, you can go here and check. Show MPLS forwarding for 5555. It says for 5555, the label is 405. That is what you saw here. All right. Right. So this is the basic lab, but there are a lot of things to learn in this. To understand the depth of MPLS, there are much more to know, understand. You just do this simple lab, you will get some experience, you will get some learning, then we will continue this. Any question on what you have seen today in the lab? What about others? All right, try and